Hello everyone. Good afternoon, good morning. I'm Vishal Kumar Mehta. I will walk you through this webinar on leading the way in quality with new age vial inspection. Before I move to the core agenda of this discussion, I would like to introduce ourselves, who we are and what we do. As many would know, Jackson Vision is founded by Mr. Vishal Shah in 2001. We are pioneers in innovative solutions and state-of-the-art product solutions. Vishal, with his unparalleled enthusiasm and passion to utilize latest technology and trends, have provided a platform to deliver a niche products which are following the market trends or future trends. We are not only expert in vision inspections, but we are also the thought leaders in tech and trace solutions as well. With our 30 plus product lines, we are able to serve our more than 600 technology partners to meet the different inspection requirements that different product needs. With more than 24 years of experience, we are almost marking around 10,000 installations, which are distributed across 95 countries. If we talk about a global footprint, we have our offices in India, US, Italy, Malta. We have our development offices in India and Europe. I'm heading one of the vision development department in India. I'll give a brief introduction about me. I have more than 20 years of industry association in vision inspections after completing my master's in embedded systems. So I have a bit of experience on how the machine and systems work, as well as how the human eye and cameras work. I have mainly worked in these 20 years on different product enhancement and product developments, mainly into the identifying the training areas and providing the new technology-based products in a different domains like medical imaging, ADAS, and machine vision inspection. Vial inspection is such a recent offerings of our Jackson Vision in such a niche area. Ideally, when we talk about vial inspection, the word itself is a self-explanatory. It's a vial inspection. But I will give a little bit of thoughts behind organizing this webinar and sharing our journey. See, it's not that we are into this vial inspection very recently. We are working on this vial inspection and providing various products and solutions to customers a decade ago as well. Even in 2000 and 2010s, we had multiple vial inspection customized solutions given to customers which were running perfectly fine on more than 100 lines. But when recently we speak to our various customers, we are constantly able to feel that there is a huge technology shift compared to the products and systems which were 10 years back and the systems which we are expecting now. There is a huge difference in terms of quality expectations and productivity expectations. I will take a particular case. Around 2010, we provided a glass bottle solution for cough syrups. Those machines, those lines were running at around 60 bottles per minute. Around that time, in our international technology partner could run the glass vials with lyophilized vial kegs at around 120 vials per minute. But if I talk about recent trends, one of our solutions to non-pharma customer who are inspecting the PET bottles with various label defects and cap defects, they are running this line at around 250 bottles per minute, 24/7 since last 2 years. So we see there is a huge technology shift. This is mainly due to a different new technologies, new trends, which are evolved over a period of time. Hence, we felt that this is a story or this is the experience which we should share with all of you, and also should able to explain what we are doing in terms of vial inspection and what are our capabilities. Now, this shift in trend is not only the need for speed, because our current solutions are able to run at north of 300 vials, 400 vials per minute 480, 500 is a norm nowadays. So need for speed is not only the requirement, but the increased quality parameters, the ways to inspect is also changing and increasing. So while inspection is a process of ensuring quality, safety, and integrity. I talk I will talk about the quality parameters in our subsequent slides. First, I'll talk about the safety. So while inspection contains a different products like lyophilized, cough syrups, different liquid materials, and hence the safety of end user or patient is a topmost priority, but also because of glass vials, the handling should be efficient. Even a broken vial can have a severe impact to the operators or user who are working on the production lines. So safety is paramount with a lot of compliances coming into the picture. Meeting the regularity standard is also important aspect of this process. In earlier days, with a generic solution, customers were happy to mend their ways to utilize that solution. This is not a norm now. This is a time for horses for courses. So customer expects a tailored solution, which are suitable to their specific needs. And with all these parameters, the return on investment is also a key aspect, how this solution is able to provide end user with options and opportunity to improve and enhance their revenue and reduce the cost. So if I talk about the technology landscape in vial inspection, it started with manual inspection systems, which slowly moved into the imaging systems. With the regularity norms, track and trace systems were added. In a recent 10 years, the usage of machine learning and AI technology has taken the quality and precision to the next level. Also, involvement of multi-angle view has incorporated different 360 coverages at a high speed. With a recent need of fully automation plants, robotics and automation with Industry 4.0 is implemented nowadays. Also, the form factor for mounting the systems, providing the solution on a product shop floor is also important, and hence edge computing is also picking up the pace. With this, all reports compliances are always an essential aspect of your solution. If I map this technology landscape over different decades, then it should look like this. In pre-1950, 1970, it was an era of manual inspection, where an operator will inspect the vial by hand picking it with the different mirrors, magnifying glasses, and backlight. Slowly that moved into semi-automatic system with the invents of conveyor, which could travel the vial on the conveyor belts. But this also could not sustain. And with emergence of different sensors and semiconductor evolution in semiconductor industry led to a high resolution, high speed camera, which invented and helped the blossoming of fully automated systems. Also, the automation softwares are matured over a period of time in this era. As we all know, that AI was in the theory, in the principal concepts since many, many years. But thorough usage of these AI technologies has started over the last 10 or 15 years of time. So this AI-driven state-of-the-art inspection has taken the inspection parameters, the tolerances, the expectations to the next level. Along with that, all the robotic integration and system synchronization is currently working on different shop floors. What we see as a future trends is more like a predictive or self-correction maintenance, along with utilizing nanotechnology to different parts of productions. So coming to the key aspects of vial inspection, it's a question of three core questions: where, what, and how. Where to fit in manufacturing distribution process, or where to fit the vial inspection in production software. What all different criteria to inspect and verify, and how to implement this visual inspection systems for vial. If I talk about where, so as a high level process of vial inspection, the empty vials are taken into the conveyor, into the trays and loaded into the conveyor. This conveyor will first clean the vials, and vials will send to filling stations. Once the filling has been completed, the vials will be moved to the capping and closure machines. From there, the vials will move to the labeling machine where appropriate labels will be pasted on these vials, and then the vials will be packed into various shippers and pallets for dispatch of material. So at a pre-fill inspection, the vials can be inspected for various foreign particles, surface defects like debris, spots, cracks, and breakages. At post-fill level, but before the label is pasted, the vials mostly will containing liquids and lyophilized will be visible. Here, the inspection criteria should be the contamination, various foreign particles, the level of the product, whether it's a liquid fill level or whether it's a powder level, also the form of the powder or the liquid, and ensuring the quality of closure in terms of any dents, any damages to creams, caps, or rubber stoppers. Once labels are pasted, the camera system can view limited portion of the vial, which are mainly the label and the closure. So here the post-label inspection covers the label defects like label flagging, torn label, label present absence or aligned label, or the inspection of the closures like cap, vial, and rubber stopper. Now, the label inspection is not only limited to pharmaceutical industry, it also requires in food and beverages as well as uh, the vials containing serums for very cosmetic uh, uh, components. So if I summarize where and what in one, then it should look like this. At a pre-fill inspection system, it should inspect for foreign particles, surface defects like scratches, cracks, molding defects like leakages, size variation, and vial appearance like vial color, etc. At post-fill label, it should check for contamination within the material or foreign particles. Also, it should check for fill level, product color, and components like cap, cream, rubber stopper. And at label inspection, it should check for label placement, label cosmetic defects like torn label, label flagging, label correctness for a label color, code verification. This is also important. Every label will have some batch specific codes, either as a part of OCV or as a barcode or pharma code or 2D code. These code verifications can also help not only from inspection perspective, but also adding the track and trace and supply chain management. And here, the components can also be inspected. So if I move on to how to implement vial inspection system, then the brute force methods are manual inspection and semi-automatic inspection. But I'm not going to touch upon this aspect because our target is to work on the new generation, new age, fully automatic vial inspection system. So fully automatic vial inspection system is not a single component or single solution. It's a package of all the different components. And these different components are the camera, which should be placed at strategic angles to capture neat and clean images. It should have sufficient lighting and required lenses. The mechanical fixtures to provide a proper camera positioning as well as managing the rejection should be incorporated. Data-driven approach should be implemented to collect and label data. The software stack has to be implemented to utilize either image processing or artificial intelligence-based components to inspect various defects. and then the synchronization or machine interface to test and run the machine in online and offline mode and provide the real-time feedback. Now, what are the challenges of manual inspection? With manual inspection, it incurs high labor cost, limited operational efficiency because it's person to person. It has inconsistency and subjectivity because the quality parameters or quality evolution varies from person to person. It definitely yields, reduce the yield. The knowledge is non-transferable. It occurs in a higher cost and low credibility because the recall rates are more, the rejection rates are more. I will take a case study, to discuss a high level cost of rejection or recall through a manual inspection. Let's assume there's false reject or recall rate is around 3%. So in every 100 vials which are inspected, at least 3 vials will either be falsely rejected or they will be recalled due to a defect has been reached to the market level. If I consider a total material cost at around $10 and with multiple operators inspecting the vial at 200 vials per minute in 8-hour shift, then for around 480 minutes, it will produce around 2,880 false rejected samples. Either these are the false rejected products which has been not utilized, or these are the recalls. And if I map into the number in the cost, that is around $28,000 cost for one particular line. And this is cost is recurring every day per line per plant. Now this is a production lost or the cost occurred. Compared to that, what are the benefits of automatic vial inspection? It has high accuracy because no human errors are involved. It has high precision. It reduces the false positive and false negative. When we talk about high precision, we are talking about in the range of 0.5% rejection or less. It of course has a faster speed, like I earlier said. The speed which are expected nowadays is around, it is north of 400 vials per minute. 480, 500 vials per minute is a norm. The results with these automated systems are consistent and measurable. It also helps in environment resilience because rework and recalls are less. And of course, the knowledge is always transferable. So with this, how Jackson Vision Solutions help? See, we are not providing the vision solutions. We are mainly technology partners enabling our customers to utilize our products to enhance their productivity and quality matrices. So it's a collaborative approach. We understand the problem statement and drill down to various scenarios. From there, we understand and utilize different tools, and we see what latest technology and tools can be incorporated. From there, we derive new ideas and provide the efficient solution. See, if I revisit the entire package of the components, then I would like to show here how Jackson Vision customize or adds value additions to this. At a camera level, we provide high-speed, high-resolution camera with the AI-driven technologies. Our lens and lights are customized. Also, we provide autofocus and auto-tunable lenses. The mechanical fixtures are precise and they are customized for the user needs. So we can provide options of either retrofitting or dedicated machines. We employ a data-driven approach, so we ensure the data integrity. So we provide reports for various different compliances. We have customizable software stack, and we provide a synchronized machine interface, which has a seamless integration and provides a fail-safe mechanism. I will talk about software stack more in detail because we are very good at customizing software stack, whether it's for vial inspection or any other component. So we mainly deal into image equation, where we can manage various interface formats like GIGI or USB as per the speed, various image formats to handle different resolutions. From image analysis, our software stack can extract the features. If it is image processing based solution, then it will be a rule based features. If we deploy AI based solution, then the features will be auto detected. From features, we identify, detect, and classify various defects. Once the detection and classification is completed, the system will work on the decision making to apply a label, pass or fail, and accordingly, the machine synchronization will happen. The output should be provided so that the physical vials or bottle has been rejected. We also provide a different data logging for reporting tools. All these software components, software stack is customizable. So if I compare the new age vial inspection solutions with respect to the conventional image processing solutions, then certain comparative parameters would look like flexibility, accuracy, scalability, cost, resources, and speed. How AI fares well compared to conventional image processing. With new age AI, it can learn and adapts to new defects very quickly. It has superior accuracy for complex and subtle defects. It's easily scalable with new data. Though it has higher initial cost and require higher processing power, but the return on investment in a longer run is very high. It also provides the higher speed compared to conventional IP, which offsets the initial cost. So I would go with the tagline that investing in new age inspection is investing in savings. Okay. These are some of the slides where I would going to highlight some of our capabilities and some of our products which are running on customer lines to showcase how different vial inspection problem solving can be done and what different inspection criteria can be incorporated. Now this is at the empty vial inspection. So here we check the empty vial for different impurities and defects. If you see, this is the software screen. I will take a moment to explain this. This is our software UI, which user can access. User can load the SKUs and simply start the inspection. The AI model, which is running at the back, take care of the requirements, sizes, etc. based on the SKU selected. This is the image display where it highlights the image which is captured and with its status, whether pass or fail. Green represents pass, red represents fail. The right-hand side corner is a real-time statistics display of how many inspection, how many batch, how many counts in the batch has run, how many are the accepted and rejected. It also provides various tools which a different users with a different access right can utilize. These all controls are following a various 21 CFR Part 11 and different compliance uh, compliances. So if I run through the video, there is a glass particle at the bottom of the vial. And because of that, this vial has been classified as rejected. This is good. This is a very small particle. This is a very small glass particle. These are some of the black particles, big, small. So these particles, like transparent glass and black particles, are identified as foreign particles, and the vial is rejected. Another solution is at field vial inspection, where we are able to inspect the field vials for different field levels and check various closer inspections like cap inspection, crimp inspection, rubber stopper inspection. This actually checks for the field level in this glass vial. This is a good vial which has a proper cap in place. The OCB on crimp is also appropriate. It has a proper fill level. Any of these criteria are missed, then the system will reject this vial. Here, the product itself is a different. Here, the level is okay, The OCR is okay. However, the cape is missing and hence the vial is considered as a failed. Another solution at the same level, field vial inspection, which we provide, is verifying the crimp defects. So for any damages in the crimp or any dents on the crimp. So if you see in front of the screen, the vial has been damaged, the crimp has been damaged, and hence it is marked rejected. This is also the rejected one. This vial has this crimp has no issues. Hence, this is classified as a good crimp, good vial. This is a very small crack or damage. This is a small dent. Sorry, my bad, guys. These are some small dents. This is without cap and dent. So all these defects are classified and the vial has been marked as rejected. Another solution at the same level we give is a closure inspection. This is a customized solution where we inspect the closure for various defects. Now this is a good closure. There are no scratches or dents on this closure. Hence it is marked accepted. This one has various scratches, various dents, which is highlighted by my cursor. These all defects are highlighted, are identified and highlighted as failed, and the vial has been marked as failed. Now, going into the post-label inspection, we provide a solution where we inspect a label for various defects like label present absence, label misaligned, label damage, and label flagging. Here in the video, this is a good vial with a good label, and the label is placed at a proper position. This is a misaligned label. The label orientation is gone for a toss, and hence it is identified as the bad product. This is the mislabel. Sorry. I would like to highlight this portion where there is a small part of label is torn, and hence this vial has been marked as a cosmetic defect and has been rejected. This one has a label flagging, and this is also marked as a failed. Now, this inspection is not only limited to vials or let's say a consumer market, but even a non-pharma where a large bottles, a PET bottles with different colors and shades can be inspected for different labels. The next slide, which is here, this is a system which is actively running on a customer line since last 2 years at a speed of around 250 bottles per minute, has this bottle aesthetic inspection where we check for label present absence, damaged label, cap placement, and cap defects. The first picture represents a white bottle with torn label. The next one is a blue bottle with a label defect, torn label. If you see, there is a huge variation in color and size as well. The next, where my cursor is a highlighting the label missing. Here, the cap has been damaged, where the lock of the crack is tightly pressed, and hence the lock has been damaged, which is identified. Also, the cap position is wrong. The cap is not fully screwed, and hence this bottle has been rejected. And the bottom one is a tagging label. with label alignment issues. These are a high-level solutions we offer. So for customer problem statement, we have an amazing idea where we can help in increasing the throughput through high speeds, enhance the accuracy with productivity, which can help into reducing the downtime and waste, which help in cost saving. The solutions are user friendly and easily trainable. We also allow to with the different tools to support various regulatory compliances, and we have customized solutions for a seamless integration. So with this, I open this forum for various questions and a discussion. Thank you. Questions?
Hi, Vishal. So there are a few questions that have come up in the chat.
Okay.
You can see the first question by Mr. Pushpender.
Mhm.
Do you see that, or should I read it out for you?
Uh, it would good if you can read it for me,
Of
else I need
course.
to go in
So
stage.
the first question is the system for both transparent and amber colored vials?
Yes, the system is supporting both amber and transparent vials. Ideally, with a color, the only difference is the optical solution, how you set up a light. So the entire solution, entire package supports both the clear vials as well as amber color vials.
All right. The next question is it's come as an anonymous. How does the system detect defects specific to glass vials, such as cracks and chips?
Okay, uh, I need to little touch upon a different lighting systems. So the optimum lighting is a very key component of the inspection system. So these scratches and dents, etc., are mainly classified as a surface defects. And with this, a dark field illumination, indirect lighting can help highlight these defects. And once the image has the optimum highlighting of the defects, our AI engines can train those images, good and bad images, and can highlight the accurate cracks, dents, etc. Here, whatever the solutions I showed with a crack, with a dents, etc., are mainly running with the backend tool of AI, which powers this detection. I hope I was able to answer to this question. Any other question?
Yes, Vishal. I'm just getting to the questions for you. Uh, with respect to inner molding defects, can they be identified in opaque containers?
Uh, this is honestly a tricky situation because with opaque containers, need to check with the opacity of the material, because if it is a semi-opaque or semi-transparent, then the defects or molding errors can be highlighted. But let's say it's a fully opaque, then only the surface defects or outer molding defects can be highlighted and can be detected.
We have one question which asks, new age inspections learns and adapts rejections. So what is, they're just trying to understand what that means, and what you imply by machine starts accepting.
Machines that?
So in the new age inspection, when earlier you said that it learns and adapts, so how
Yes.
exactly does it go about when the machine starts accepting or understanding rejections?
Okay. So ideally with AI solutions, the first key aspect is to collect the data, classify and label them, and then train your AI engine. Once the AI engine trains, then once it is deployed on the site, the system can be tuned such a way that whatever the inspection criteria is it has inspected and the classification it has done, pass or fail. User can also provide it through a back channel to the AI engine so that it can adapt the new variation, or it can add the modifications in lighting or different conditions or different sizes of defects, and map into a more accurate or more precise improvement. It also helps in some of our standard software. We provide a user an option with storing those images as a part of like live analysis tool, where user can also on the shelf on the run classify those images with a pass and fail, whatever the inspected images they have, and the system, the AI engine can help auto tune it. This is how the new age vial inspection try to have a feedback loop to auto tune or auto learn.
Vishal, Mr. Appa Sahib had some questions and he has raised his hand. Mr. Appa Sahib,
Okay.
I have unmuted your mic so you could speak, and it would be great if we could have you on camera as well.
So you
Hi,
want to
Appa
know
Sahib.
that? Yeah, hi.
Hi.
See, the Vishal, the question is what you said is industry-wise is a doubtful acceptance. For example, let us say I have a machine
Mhm.
and willfully, if the defect in the AI learning model, if I willfully make it an acceptable, then
I
machine
will,
learns it as acceptable, then what will
mhm.
happen?
Sorry.
Now
So,
you
sorry, can you
said,
come again?
now you said the user can decide, the machine will capture an image and will keep
Mhm.
it as stored for
Mhm.
user's intervention.
Mhm.
User, let us say, sees the image
Mhm.
and decides that it is acceptable.
See, the AI base, the main concept with the AI base is to tune, classify, and train the AI models with some sort of a data. Okay.
Yeah.
Now, let's say if you just train the data very
Yeah.
wrongly, then it is
Yeah.
able to is going to malfunction. It's like
But
if we
that,
train our mind that this is not apple, this is the coconut. Then over a period of time, it
yeah,
is going to
that
accept it as a
that
coconut.
choice should not be there. So, yeah.
So important aspect is the quality of your data which you are training the AI engine.
Okay, understood.
Okay. Yeah. Any other
Thank you so
question?
much, Mr. Apasab. I'm just going ahead with some other questions that I have seen. Are there any limitations when inspecting colored or opaque vials?
Uh, okay. So like I earlier said, the amount of opaque is also important because the entire opaque vials will have a limitation to identify the scratches or dents or surface defects which are on the other side of vial walls. So with the entire opaque vials, there will be limitation that the system can only view which is in front of the camera or which is in the field of view. Uh, that the major limitation. Other major limitation is with opaque vials, the different lighting required and full 360 view of inspection is required. So mainly the optical and software or the camera components shall be placed in such a way that all different facets of vial surface is visible, but at the same time the lightings which are set for all these cameras are not disturbing the other imaging cameras.
All right, thank you. We also have a couple of more questions. How do you manage pharma qualification with AI software?
Okay. This is actually a very interesting question. uh, See, basically, AI is a backend part. It's the engine. What we say around 10-15 years back, there was an image processing engine. We can consider this AI or image processing as a component which is running in the backend. Its core concept is to view the image, process the image, and identify the defects. The entire validation is through verifying a different challenge tests and good vials in a production run. So normal pharmaceutical validations are run with whenever there is a validation, the entire process of a couple of days is placed where user will challenge the system with various defects. With good vials, they will observe the, the statistics, basically, which is called a truth table. You can say user will observe the false positives, false negative, true positives, and true negatives. The false negative should be within the range of 0.5 or less than that. However, there should be zero occurrence of false positives. So any damaged vial or any damaged system component shall not go out of the production line. So customer with different samples challenge the system, record those, and validate the system. The validation system is same or similar the way it was functioning with the image processing tools as well. It just, rather than image processing tool, which is rule based, here this is an advanced tool, which is a AI based tool.
Okay. Mr. Praveen Garud has asked a question. Is this system using neuron software for learning? That's his first question. And the second question he has is, does it cost every time for new workspace with, be it color change, label change, etc.?
Uh, okay, so there are two ways of training the data. If all the SKUs are available, okay, then those data can be prepared like uh, see, color change is not a, a very big feature. Ideally, the system trains which are the unique features. Like it can adapt to color changes, but let's say label changes where the artwork, where the details has been changed, then those label changes has to be incorporated within the training module or AI engine. Okay, so there are two ways of working out with this. One is a pre-known SKUs are already trained and are in place with the system. Any new change, if it's a subtle change like color change or something, system should adapt itself. If not, at least the quick training with help of the previous SKUs would be very fast. But if there is a label change, those changes should be incorporated as a new SKU in a new training. I think someone has asked
Vishal, how
how is.
easy is it to integrate the system into an existing production line?
See, I would exaggerate if I would say it's very easy because, like in our value additions, when I spoke, I talk about the customized mountings. So as per the process, when we interact with the customer, our even mechanical teams visit those lines and understand each and ask each and every part of the machine. From there, they derive the mechanical stuff, mechanical mountings. And with that, we provide two options to customer. They can easily retrofit this system into their existing conveyor, or they can, add a space and get our entire conveyor, entire machine. So it's easy to integrate into the system. Normally we call it as a retrofit. Okay. Which requirement is most challenging in vial inspection? Okay. Out of these various requirements, the surface defects are a little bit challenging. The reason for this is the more the transparency and opacity of vial material changes, the behavior and appearance of these surface defects changes. So it needs a specialized lighting and placement. So compared to other defects, I could say that surface defects or molding defects are challenging to inspect, but with expertise, mechanical structures, and lighting positions, those inspection criteria can also be met. Any other questions?
There was one question regarding compliance, understanding the compliance or with EU, GMP, FDA, and other regulatory standards.
Hmm. Yeah. So we comply with all different standards like GMP, FDA, 21 CFR Part 11. So our system, the mechanical and software, they are complying to the industry standards. It's by default in nature of our all software solution of our all product solutions.
Perfect. I think we have covered all the questions. Does anyone have any other questions they would like to ask?
Meghna, we've got one more question in the chat.
Yes, yes. So the question is, can the system create its own modified batch samples to be trained based on
Mhm.
batch sample photos, which means the training process is shorter? How many photos and batch products should be provided to train the system?
Okay, I will answer this question in two to three different parts. The first one, can the system create its own photo of damage? Uh, System can create, but we have never tried. So our software actually takes a picture and evaluates it. We have never generated artificial photos with the defects to highlight the defects. Coming to second part, can the photo of defects help training the models faster or training the system faster? So yes, those photos can help. Ultimately, taking the data from the camera feed is also sort of a photo. The only challenge which comes with a photo is a missing out on a different aspect ratios, different size of the defects, and may happen that those photos, uh, which is taken for small vial with a very small crack, but with a mobile phone or with a high resolution system from very near, it has been taken and the defects are looking very large. So it can actually jeopardize the size and appearance of defects. But however, if photos are accurate or near accurate, then those can be used in training systems to train the system faster. Uh, the third point I would like to discuss on the speed or how fast the training can be. Now, our products, with a customization, we provide two types of scenarios. One is a classical AI systems where we need few more data to train, and they are pre-trained. Whereas we also have a tools and system with a edge learning hardware where the system can take around 10 or 15 photos on the live run, can classify them on the fly, and can train the model, and the inspection can be started. Uh, that was my answer to Mr. Thomas Kwaka. I hope I was able to answer to your question. Any other question? Any other case study or some scenarios any of the participant would like to discuss, or someone would like to discuss some of their challenging needs? That also we can incorporate.
So, Vishal, one of the questions that I usually get is while inspection can only be done when it's vertical, or after it's put horizontal as well in blister or anywhere else they are put, can it be done then as well? And what all things can be done when it's horizontal, and what all things is possible when it's vertical comparatively?
Okay, so when the vials are placed horizontally, its liquid is or its material is let's say lyophilized powder or cake is going to spread across its height, and hence it might not be able to efficiently allow to detect the impurities or foreign particles or contamination within the products. However, with those vials, horizontal vials, the system can easily do the surface defects, the field level, etc. Okay. One of the requirement which we have evaluated few months back was reptiles where plastic vials containing the liquids with a specified range of levels. We were also able to identify the field level into those. Anything, any other question?
I think we have covered all our questions, Vishal.
Mm-hmm.
Thank you, everyone. Thank you for joining us. Thank you for your time. You can feel free to write to us at marketing@jacksonvision.com. I have given our contact information in the chat. Please do feel free to reach out to us for any queries related to vial inspection, and Vishal will be more than happy to answer your queries.
Sure.
Thank you,
And I
everyone.
think,
Have a nice day.
yeah, I thank everyone for spending this hour with me on this webinar. Thank you all. Thank you. Bye bye. Have a nice day.